I think historically this is just a tough concept for students, and that's not because as math teachers we want it to be difficult. Um, domain is all about input. Range is all about output. I probably should have this arrow going the other way, right? Domain, that's input, like that arrow's going in. Range is output. Let's go with, here we go. Let's be really mathematical here, right? This is this is a microwave, right? And it's got like a door on it. You kind of get an idea of, how big a microwave generally is. We got the handle here, right? So let's say this is our function, right? Like, you're going to run this thing for, I don't know, let's say like, 60 seconds. Like, so you're going to put things in the microwave, right? You're going to run it for 60 seconds, and you're going to get things out. Like, in, put, out, put. We'll go input is in, I don't know, like blue, right? Because you put it in the microwave and it's cool, and the output is red, because you get it out of the microwave and it's warm or it's hot. Okay, we're going to talk about like the domain of your household microwave, right? Okay, let's just list the things in the domain, some of the things. Popcorn. I don't know. Pop-Tart. No getting on me for my spelling here, right? Like those are all reasonable, right? Like it's kind of, we could even talk about practical and theoretical domain here. Practically speaking, yeah, popcorn, Pop-Tart, those make sense to put in your microwave. Here's one thing that, theoretically you can put it in your microwave. Not a good idea, right? If it actually fits in the microwave, I mean, come on, you could put a pillow in the microwave. It fits. It's not practical, but theoretically you could, take a standard sized pillow and shove it in your microwave. Just like you could put a, here once again, bad idea, but it fits in the microwave, right? You could put a fork in there. So let's say, like, we're just talking about the theoretical domain, not practical at all, right? Just theoretical. Theoretically, you could put all those things into the microwave, right? They fit. Think about this. They fit in that space. Not all microwaves are the same size, but they're pretty close, right? Those things fit. You see that like infinitely many things, right, that go into a microwave. Now, let's think about things that are not in the domain, right? Things that would not be a part of the domain. So not in the domain. Okay, so just like, right, think of anything that's, not going to physically fit in the microwave, right? Like a hockey stick. Not going to work. Not going to fit in the microwave. Even good idea or bad idea, it's just not going to fit. Your HD TV, 46 inches. You're not going to put the 46-inch plasma in the microwave, right? It's not in the domain, practically or theoretically. It just doesn't fit, right? Now, let's talk about range, right? These are things that are coming out of the microwave, right? So just, in your head, think of a few things that come out of the microwave, right? Like hot water. I don't know, pasta. Warm pasta. We got like Pop-Tarts are gonna come out of the microwave, and melted butter. When we said, hey, we're gonna put it in the microwave and you're gonna run it for 60 seconds. These are all things that could come out of a microwave after it's run for 60 seconds. It's kind of cool, and sometimes helpful to say what are things not in the range. It's domain and range are really, you look at them and sometimes it's, actually, most of the time, it's a lot easier to describe what's not in the domain or what's not in the range. And once you have a description of everything that's not in there, well, ultimately you have a description of everything that is in there. So, not in the range. You could probably argue with me here, and, science guys would figure out a way for it to happen that after you run the microwave for 60 seconds, it's still there. But I'm going to go ahead and say ice cube. I don't think it's in the range of the microwave. Another thing, not in the range of the microwave would be a, I don't know, cow. Like full size, right? Well, it's not in the domain. It's not going to be in the range. Well, not always, right? You can put an ice cube in the microwave, but you're not going to get an ice cube out. But a cow, you're not going to get a full size live cow out of the microwave. It's not going to happen. So I took you through all of this just to consider inputs and outputs. And the microwave was our function. Things you put in are in your domain. If you want to talk theoretical and practical, theoretically, your only limitations on input would be size, right? As long as you can fit it in there, shut the door, punch 1 minute, hit start. If it fits, it's good, right? It's in the theoretical domain. Now, practically speaking, says, okay, what makes sense to put in the microwave? Not an egg, not silverware, not tinfoil. Those are not in the practical domain of this function we've called, microwave. F of x equals the square root of x. Domain, we're talking about inputs. Range, we're talking about outputs, right? So this is like your x's, these are your y's, these are your input, these are your outputs. Input and output. Okay, so the domain of this, I'm going to use interval notation, right? So think about all the numbers that you can plug in, right, that kind of fit underneath this square root. Well, we know the square root is kind of a special operation because it's limited. You can't have negative. You can't take the square root of a negative number. I mean, if we're talking about imaginary numbers, we can, but in the real number system, we're not going to be able to take the square root of a negative number. So our domain is going to be, it looks like this. That's how you describe it. The set I've written there, right, like that says all the numbers including 0 up to infinity. And the reason that the brackets are different, this bracket here says you include 0. I'll show you on the next problem we won't include 0, and the bracket will look different. But I've described all numbers from, all real numbers, right? Real numbers from 0 to infinity, including 0. Including 0. Now the range, right? Okay, so think about all the things you're going to plug in and take the square root of, right? Well, after you put a value in for x, right, and you take the square root of it, what kind of things are you going to get out? Like, is 10 going to be in the range? Yeah. What would you plug in order to get, a value of 10 out of f of x? Well, 100. You take the square root of 100. So yeah, you can get a lot of different values out of this function, but you're never going to take the square root of something and produce a negative number. So here, once again, you're looking from 0 to infinity. Right? Well, why'd you put a square bracket on 0? Well, because if you input 0, the square root of 0, right, that is your input, you're going to get 0. There's your output. Right, there's our domain and range of the square root of x. Now, here's something you have to be careful of. Right? It's not always going to happen. Notice the lowest number in our domain, if you plug that in, like f of 0, you get 0. That produced the lowest number in the range. Okay, this is not always going to happen. The highest number in the domain, well, it's not really a number, it's infinity, it's a direction. But, when you plug in the square root of infinity, you're going to get, infinitely large values again. So, a lot of students will see this relationship, right? And they'll say like, oh, so all I got to do is find my domain, and then the range is really easy. You just plug in the low number and the high number. That's not always the case, right? It doesn't always happen. I'm going to draw you a graph here that shows you. Let's say you have this function right here. Okay, there's your function, right? Let's say this this is like 2. We'll call this. We'll call that 0.5, right? On the y-axis. Here's your x. Here's your y. We'll call this 4, 5. Way up here. Let's call that like 10. Let's call this, 15. So if you looked at this graph, right, and said, what's the domain and range? Domain and range. Right, okay, domain, that's x. Range, that's y. Right? Okay, so all of the x's, like look at this curve, right? It's made up of infinitely many points. A better color. Infinitely many points, right? For example, when we're right here, right? When we're at the end of this thing, red. The coordinates of this point are, you go over 15 and up 10. Well, guess what? 15 is in the domain, right? 15 is in the domain because it's a point on this curve. 10 is a y-coordinate. It's in the range. So if you went and said, okay, what about right here? Well, this is like the point, I don't know, like, let's call it like 14, 4.5. Well, hey, 14 in the domain, it's an x. 4.5 in the range, it's a y. As you trace along this curve, consider all of the ordered pairs you're going to encounter, right? The x's and y's. What do you know about all of the x's you're going to encounter? Starting here, going through this, and ending here. Are they all going to be like contained in a set of numbers? The answer is yes, right? The lowest x you're going to get to is 2. And you actually do get to it. This point has an x coordinate 2. The highest x, the largest, is 15. Now it's really important also to notice, I can describe this domain with one set of numbers here, because not only do I get to 2 and I get to 15, I achieve every value in between them. I think the range, well, alright, it's still kind of like curve, writer, tracer thing, right? If you consider all the y values. So let's go back to black, right? You're starting here. The y value is 4. Tracing along this, you got y values of 5. Okay, you got y value of a half. Coming up here, y values are increasing. They go up to 10. Well, go ahead and, if you jot some of them down, go to orange. Like, consider all the y values that you achieved. Right? Well, the lowest y value as you went along this curve was, that was down here. That was a low y value of 0.5. The highest y value was, oh, that was at 10. That was at the end. So here's a case where the low number on your domain didn't produce the low number on your range. The high number, right, the 15, that was responsible for the 10. And it's not always like the low, if the low doesn't work, the high will, or if the high does work, the low will. I mean, you just have to be conscious of it and don't oversimplify it and say, well, I'll just plug the lowest value in on the domain to find the lowest value in on my range. That's not going to work out well for you. Sometimes it will work. Sometimes it won't. So you're just going to try to use number sense and think about inputs and outputs. Right? And I'll have another video after this.